Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's upload, which is our final upload that we're going to be making on this particular paper, we are looking at the May-June 2023 exam paper or exam solution. Of course, a link or links will be pinned in the description of this video where you can find the two previous parts, that is in fact questions 1, 2 and 3, that is in part 1, and questions 4, 5 and 6 in part 2. Now of course in this video we're going to be going through questions 7, 8, 9 and 10, and we're going to be bringing this to the end. Now the reason why I do the videos like this is, of course, students will have particular interests, particular areas that they want to focus on. They may not necessarily want to watch an entire paper, but they definitely want to kind of focus on certain areas in the exam paper that they are struggling with. So hence why I kind of make my videos in 40-minute sessions, and it's really sometimes geared towards having the students to stay focused and learning quite a bit in a short space of time. All right, now of course, if this is the first time on the channel, I do provide mainly tutorial videos for students that are participating in the year-to-year Caribbean Secondary Examination Certificate exam for mathematics. But of course in the future more videos will be coming out on wide areas in math. So of course, if this is the first time here, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and do not forget to share this out. It really does help the channel to grow whenever you hit the like button and you click the share button. So without further ado, let's dive on right in and bring this exam paper to the end. Now, a sequence of design is made using black disk and white disk. The first 3 designs in the sequence are shown below. Now, what we're looking at here, we have to make an observation. This particular type of question is an investigation question on a CSEC curriculum. We have to make an observation as to what is it that we're observing, what kind of patterns can we follow here. Now as I'm looking at this, the very first thing that caught my eye is the fact that okay, we see some clear disk here and some black disk. The very first thing that catches my eye right away is the mere fact that they're in design 1 I have 3 black discs at the bottom. Then I realize that in design 2 I have 4 black discs. Then in design 3 I have 5 black discs. So it seems as if the bottom part here of the designs, they're increasing by 1 for each design. So right away then I can safely say then, let me just zoom up here for you. Right away then I can safely say then that this is going to be 1 here, 2 here, 3, 4, 5, 6. That's the very first thing I recognize, because they said in the space provided on the grid above, draw design 4. So that's what I'm focusing on. And now I recognize also that the black disc at the side, they are increasing also by 1, starting off with 2 here. Then it goes to 3, then it goes to 4. So already I know that this is going to be, say, 1, 2, 3, 4, 5. That's what I recognize immediately. All right, and then now realize that the rest of this here is basically going to be like a single white disk at the top here. So I'm gonna have a single white disk at the top here, like that. And then now we're gonna fill out the spaces here with white disk all the way out here. Okay, like that. Seems as if that's the pattern that is being formed here. Okay, because see here we have 2 white disc here, then we end up with 3 white disc here, then we end up with 4 white disc along with a black one. So we're gonna end up with, say here, okay, so it's 1 black disc to 2, 1 black disc to 3, 1 black disc to 4, so 1 black disc to 1, 2, 3, 4, 5. And it's basically gonna keep that pattern going right across. Here we have 1 black disc to 3, 1 black disc to 4, 1 black disc to 5. That's it right here. Then we have 1 black disc to 4, 1 black disc to 5. So we're gonna have, okay, 1 black disc to 4, 1 black disc to 5, and then we just have that odd white disc sitting at the top. So this seems to be the shape that is matching design 4. So when you guys get this question, it's just a matter of kind of looking at what patterns are you seeing. You know, are the disc increasing by 1? Are they increasing by 2? You pretty much have to have very good observational skills when it comes to these types of questions. So hopefully you guys catch on to that. You guys may see it a little bit differently from a different angle, but hopefully you guys catch on to how I had created that design. Now we go on down here, and it says that the number of white disc W, the number of black disc B, and the total number of disc T from that form each design follow a pattern. The values of W, B, and T for the first 3 designs are shown in the table below. Study the pattern of numbers in the table. Complete rows 1, 2, and 3 in the table below. Alright, now when it comes to this part of the paper, guys, and many students sometimes find a challenge in figuring out the answer, you really have to have very good observational skills and numerical pattern skills here. And most of the time, based on, you know, trends, based on the types of questions that CSEC normally sends comes on the paper, then you often find sometimes that there's a relationship between the columns here. And so the very first thing that I observed here is the whole fact that, say here, you have this repeated bracket here, 1 times 1, 2 times 2, 3 times 3. So right away I can see that basically the number of disc here, not the design here, is repeating itself. So 1 by 1, see it here, 2, 2 by 2, here you have 3, 3 by 3. So if this is 9, right away I know that this is 9 by 9. And notice now that we have plus 1, plus 2, plus 3. So it's like you're adding on the design type here. So this is going to be, say here, plus 9 here. So that's 9 times 9 plus 9. You see 3 times 3 plus 3, 2 times 2 plus 2, 1 times 1 plus 1. You see that pattern that's been created? Yes, that is it. And then you have that constant here that's been added. So that's plus 1, plus 1, plus 1 here. So that's going to be plus 1 here. And then obviously you would have to have worked out this here. So if you say 1 times 1 is 1, 1 plus 1 is 2, 2 plus 1 here is 3. You realize here that we are working this out to get the solution that goes here. So 9 times 9 is 81, 81 plus 9, that is 90, 90 plus 1, that is 91. Okay, very simple then. So you can see that it also follows this pattern here, 20 by 20 plus 20 plus 1. So that's 421. But remember we said that whatever the disk type is here, that's basically what's repeating itself here. See, 3, 3 times 3, 9, 9 times 9, 2, 2 times 2. So if you have 20 by 20, it means that this is the 20th design there. And that fills that spot there. Okay, so you'll notice then now, let's go over to this side here, and then you recognize nicely that we need to fill out this spot here. And if you look carefully, you will in fact realize then that there's a relationship between the black disc and the design type. Now if you notice here that let's see here, we have some sort of relation. Let's try to see if we can find a relationship between the design number or the design type here add the number of black discs. And what I like to do is that I like to experiment. I like to try stuff. So I'll say something like, let me try to multiply, say here, the design type here by 2, because if you notice here that this, say here, is going up by 2. See, this type 1 has 4 black discs, and then design 2 here, it has an extra 2, and then design 3 has an extra 2. So right away I know that there's an increase of some sort by 2. So now I notice here that if I just experiment a little bit and I say, hey, 2 times 1, I realize that I get 2. But then if I add an extra 2, I get 4. Now, it works for this one, but we have to see if that particular pattern works for this one as well. So if I go ahead and I say 2 times 2, that gives me 4. And then 4 plus another 2 here gives me 6. And then it seems to work for that one. So let's try the third one here. It goes 2 times 3, 6, and then 6 plus 2 is 8. So you see that there's a consistency in my experiment there. So how did I choose the number 2? I just kind of look at what's happening in between the numbers here. And then I look at what can I do with that increase. Do I multiply? Do I add? Do I subtract? Do I divide? It kind of depends on the table. So right away I know that basically what I'm doing then to get this value here, I'm actually multiplying this number here by 2, then I'm adding 2. So this looks to be, say here, 2 times 9, that is going to be 18, and 18 plus 2, that's going to give me 20. So right there and then, that's what I'm looking at. That is 20. And you guys can actually check it. If you go ahead then and subtract, say here 3, if you go ahead and say 9 here, which is what we're looking for, minus 3, that's going to give us, say here, 6, yes? And we know it's increasing by, say here, 2, so we know that it's going to be times 2, that's going to give us, say here, 12. And if you add the 12 extra discs that is between design 3 and design 9, you notice that 12 plus the previous value 8 will give us, say here, 20. So that's also a very nice way of doing it then. All right, so you could do it that way. And then obviously then you can see over here is 111 that's already filled. Let's go down here. So we know right away again how we got that 20 is the same. We're going to get this value here. It's going to simply be 2 times 20, that's 40, and 40 plus 2, that is going to be 42 there. Okay, and so now we need to figure out how do we actually get this value over here. Now if you look at the title here, it says that the total number of disk T, that means when I add number of white disk to the number of black disk. So notice here that 3 plus 4 gives us 7, and so it works for that one. Let's try this one here. 7 plus 6 gives us 13, and 13 plus 8 here gives us 21. So right away, very easily, you can see here that if we were to add 91, which was our calculated value, to 20, which is also our calculated value, then you realize then that it is actually equal to 111. So we have just confirmed that our previous observational formulas was in fact correct. So then we can simply just add 421 to 42, and that sounds like 463. That goes there. All right, now it's time to create the formula basically that's giving us the answers in the table. So then what can we do here? We know that the disk is repeating itself here, so we know that whatever number is here basically it's multiplying itself. And when you multiply something by itself, basically what you're doing is that you're squaring the value. So let's say that if n represents everything over here, then it's going to be n squared plus, obviously, we're going to add n back to it. Always going to be adding back this type to it. So that's n squared, 20 times 20. So that's n times n, which is n squared, plus n, plus an extra 1 here. All right, that's going to be the formula that we could possibly use to get whatever value we wanted, say here. Okay, and then of course we know that all along we've been just multiplying this type by 2 and adding 2. So right away we know that this is going to be 2 times the this type, and then we're going to be adding 2 here. Okay, and then obviously then we know that it's going to be over here, we're going to be adding the number of black disk, say here, with the number of white disk to give you the total number of disk. So basically then what we're doing is that we're going to be adding this here, this formula here, plus this one to get the formula here. So let's go ahead and do that. So that's going to be n squared plus n plus 1 plus, say here, 2n plus 2. Notice here that we added the 421, which is being represented by this formula down here, and we added the 42 to get the 463. So we have to add this formula that we've just created here to this formula right here to give us the formula that goes right here. So then grouping like terms, n squared, we know right away that n plus 2n, that's going to be 3n, and of course 1 plus 2 is in fact 3. So what goes here is n squared plus 3n plus 3, and that gives us a wrap on that filling out the table. All right, so hopefully you guys catch on to that one already. I did an example like this in the most recently uploaded video, January 2024 recent examination paper, so you can also check out that particular table one, and many more will be coming up because I'll be releasing the papers backwards, 23 years, 22, 21, 20, January and May. So you guys have a lot of opportunities here to really dive into the whole practice then. All right, now Stephen has 28 black disk and 154 white disk and wants to make design 12. Explain why it's not possible for him to make design 12. And it's just 1 mark, so you just know it's just really just a little bit of observation here. Now if we go back to the table here, and we know that design 12 is going to come in between design 9 and design 20, let's use the formula here. Let's use the formula here to figure that out. We know that if it's design 12, it's going to be 12 times 12 plus 12 times 1. That's going to give us the total number of white disk. So we know right away that he has 154 white disk. That's what we know for certain. So if we say 12 times 12 plus 12 plus 1, then 12 times 12 is 144, okay, plus 12 plus 1. So 144 plus 12, that sounds like 156 plus 1, and that's equal to 157. So basically then he has more white disk than what he has. Sorry, it requires more white disk than what he has right away. So it requires 157 white disks to make design 12, pardon me, and he only has 154. And so if you go ahead then and you also look at the formula for the number of black disk, then you'll realize that the formula for black disk is 2n plus 2. So that's going to be, say here, 2n plus 2. So that's going to be 2 times 12 plus 2. So that's 2 times 12 is 24. 24 plus 2 is 26, and he has, say here, 28. So he has a little bit more black disk than what is required for design 12, but he has less white disk. So he doesn't have enough of the white disk to make design 12. He has more than one of the he has more than what is required for black disk, but he has less than what is, pardon me, he has more than what is required for, pardon me again guys, I'm so sorry, he has less than what is required for, say here, to make the white disk, and he has more than what is required to make for the black disk then. All right, so that's just kind of like what you'd have to write down to conclude your solution. So that brings us then to the end of, say here, question 7. And so that was a pretty nice question there. Okay, not very challenging. I've seen many more examples like that where CSEC really puts a number on the students and definitely opens up your thinking. So for that particular paper, if you did that exam in that year, you got away with a little bit of leniency there by CSEC. Now we're going to be moving on to section 2 of the paper, where we have 3, again, compulsory questions that you must attempt. Now for question 8, functions, relations, and graphs mixed with a little bit of algebra. So complete the table for the function y equal negative x squared plus x plus 7. Now students, when you get a table like this, then you need to fill out. In order for you to fill out the table here, you're pretty much going to be substituting then the value that is up here in the equation right here, and then you work it out separately, and then whatever result you get, you put it right in the space here. So for minus 3, which is missing, is going to be negative, open bracket, negative 3 squared. Gotta be careful, guys. It's negative x squared, so it's negative, open bracket, negative 3 squared, say here, plus negative 3, and so this is going to be plus 7. Now a common mistake here, I've seen it where students tend to go ahead and distribute the negative and then square the result. That's problem, and when you try to plot your graph, it's going to look a little bit offset. So remember that exponents comes before multiplication, so then we're going to have to square the negative 3, which you're going to get positive 9, but the minus lands in front of that positive 9, making it negative 9. Many of you guys would have already made the mistake by writing down 9 here. So remember, square first, distribute second. And now of course plus times minus is minus, so that's minus 3 plus 7. Then you just basically end up here with minus 12 plus 7, and that's equal to, say here, minus 5. Okay, so that goes here. We can do this again with minus 1, so that's going to be minus, open bracket, minus 1 squared, yes, and that's going to be, say here, plus negative 1, and that's going to be plus 7. So same procedure here, square the 1, okay, let's square the negative 1, you're going to get 1, negative 1 here, plus times negative is negative, so that's minus 1 plus 7, so that's minus 2 plus 7, and that works out to be positive, say here, 5, so that goes here. Do the same procedure with 1, so that's going to be negative 1 squared, alright, and that's going to be, if you want to put the 1 in bracket, that's up to you, but it's fine, minus 1 squared, and that's going to be plus 1, and that's going to also be plus 7. Okay, so we're following the formula then, and so minus 1 squared, that's going to be minus 1, say here, so we square the 1, okay, negative 1 plus 1 plus 7. Negative 1 plus 1 is 0, so that's going to be equal to, say here, 7. So 7 goes here. And then of course, nicely, we have 3, so that's going to be 3, that's negative 3 squared plus 3 plus 7, so that's minus 9 plus 3 plus 7. So minus 9 plus 3, that is going to be minus 6 plus 7, and that works out to be 1. So 1 goes here. All right, students, so when you see this particular type of question, that's what you're going to do in order to complete the table. All right, and you definitely have to just kind of pay attention to the function that they give you. Sometimes they'll give you various types of functions, or quadratic functions mostly, or they might give you some sort of other like a temperature curve, curve. It just kind of depends. So basically, whatever it is that they've provided up here for you, then you replace the number given and simplify and get your answer. All right, beautiful. All right, let's get on to the next question then. Now it says on the grid below, draw the graph of negative x squared plus x plus 7, and you are to use the domain minus 3 less than or equal to x, and at the same time less than or equal to 4. So basically what they're trying to say here, students, is that you're just going to be plotting the points that are actually in the table here. So minus 3 matches to minus 5, minus 2 to 1, minus 1 to 5, 0 to 7, so on and so forth. So let's take our time and do our plot. It's so fortunate for us here that they have already drawn our axes for us. Now, many times if you don't pay close attention to the axes, guys, it's crucial, it's super important that you observe if it's a 1-to-1 scale or has the scale been adjusted. And you can see that it's a 1-to-1 scale on the y-axis, but there's a 2-to-1 scale on the x-axis. So just be a little bit careful when you're plotting your points. So every 2 represent 1. So this is half, this is 1.5, 2.5, 3.5, so on and so forth. All right, so let's get into that then. Now we have, say here, minus 3 to minus 5. Let me just write that down right here so it's easier when I move my screen. Minus 3 to minus 5. Then we have minus 2 to 1. Then we have, say here, minus 1 to 5. And then I have 0 to 7. I have 1 to 7. I have 2 to 5. I have 3 to 1, and I have 4 to negative 5. All right, good. Okay, so let's go down to our, say here, graph and look and plot then. So let's get into it. So now we end up with minus 3 to minus 5. So that's going to be, say here, minus 3 to minus 5. So that's 1, 2, 3, and up 5. All the way up here. Oh, it's minus 5. Okay, so minus 3 and down minus 5 all the way here. Okay, so that's our point right here. Let me just use a different color, much brighter for you. So that's going to be right here. Okay, beautiful. Next, we're going to have minus 2 to 1. So that's minus 2. Minus 2 to 1, so that's minus 2, up 1. That seems to be right here. Okay, all right, let's see, let's continue. Hopefully we didn't make a mistake earlier. All right, and then we're going to go to minus 1 to 5. So that's minus 1 to my left, and up 5, 1, 2, 3, 4, 5. That's right here. Okay, curve seems to be forming quite nicely. Then we're going to move on then to 0, 7. So that 0, which is in the center of the Cartesian plane, and we're going to go up all the way to 7 here. Okay, so let's do that then. All right, and then we're going to go on to next, say here, 1, 7. So that's 1 across, 1, 2, 3, 4, 5, 6, 7. So that's right up here. Okay, nicely. And then of course we're going to go 2 to 5. So that's 2, 1, 2, 3, 4, 5. That's right here. Okay, so it seems like we're forming the curve quite nicely. And 3 to 1. So that's 3 to 1 right here. And then of course finally we have 4 to negative 5. 4 to negative 5. That's 1, 2, 3, 4, 5. All the way down here. All right, and those are our points. It says on the grid we should draw the graph, so we're going to go ahead and draw that graph. Okay, so let's go ahead and use a red here and just kind of smoothly draw our curve. So here, let's focus, guys. Okay, let's try to do that a little bit better. I think I almost got that one right, guys. A little wobbly. Okay, nice. Coming around nicely. It's not the best curve. If I wasn't on my computer screen, that would be a lot easier to draw. So it's a little wobbly, guys, but you see up here, you want to ensure that up here it has like a little mouth. Okay, so you want to kind of make sure that when you're drawing this on the actual exam paper, you have a little mouth like that. Just go up and come over like that. Okay, so mine wasn't wonderfully drawn, but we're going to make do with what we have done here. Okay, it's a little bit more difficult to be drawing on the screen than to be drawing the actual people here. All right, so there we have it. That's our graph. Let's see what they have asked us for here. They say write down, say here, the coordinates of the maximum or the minimum point. Well, in this case here, we're looking at a maximum point. That's what we're looking at because it's all the way up here. So the maximum point, then it says write down. So it says write down an estimate then. So to meet the maximum point here is not fully drawn correctly. I'm gonna think maybe that it's, say here, 7 point. It's gonna be a little bit more than 7. It's not gonna be like exactly 7. So it's probably gonna be about 7.246 probably about 7.2. Okay, based on the scale, 7.2. Each of these represents 0.2. So I'm gonna guess, say here, 7.2 for the minimum point. So I know right away then that in order for, say here, the minimum point, we know we'd have to go across, say here, a half. Okay, we have to go across a half here and go up about 7.2, maybe 7.25, I don't know. I'm gonna go ahead and I'm just gonna write 7 point. I'm gonna go ahead and say here a half, and I'm gonna go 7.25. This is just a guesstimate. Okay, I can actually confirm this. I know for certain that the x value is a half, but I'm not so certain about the 7.25. But I can confirm this if I wanted to. I can go ahead and use a formula that I had shown you guys in the previous video. That is in fact the formula 4ac minus b squared over 4a. I don't think it's necessary. It's just 1 mark, so you just have to like make a guess. So I'm gonna say 7.2, 7.25. I'm gonna run with it for the purpose of the video. I'm just gonna leave it at 7.25. We're not gonna dive into the exact value. We know it's gonna be a little bit more than 7, and it's a little bit less than 7.5. So I think that we'll safely either accept or give away that mark on the exam. Okay, but you guys let me know in the comments if when you drew your graph, if it's a little bit above, say here, 7.2 or so. Okay, now it says write down the equation of the axis of symmetry. Now the axis of symmetry equation then is in fact going to be x equal minus b divided by 2 times a. All right, that's the formula that you can use to derive the axis of symmetry equation. So this is the axis of symmetry equation formula. So where do I get my b and my a? Now remember that we have been given the equation of this graph, and this graph here is negative x squared plus x plus 7. So negative x squared plus x plus 7. So it's negative x squared plus x plus 7. So we know that the b value then is simply going to be here. The a value is going to be here. C value is going to be here. So that's going to be that x is equal to minus 1, because there's a 1 in front here, divided by 2 times minus 1. Alright, and so that's going to be equal to minus 1 divided by, say here, 2 times minus 1. That's going to be equal to minus 2, and that's going to simply be then, say here, positive a half. Okay, so that's positive half. So the axis of symmetry equation is x equals a half. X equals a half, which is exactly what we got right here when we said that the x value is a half. So you're good. Now, use your graph to find the solutions of the equation where negative x squared plus x plus 7 equals 0. Now, when they ask you to use your graph, right, even though there are alternative methods to getting the answer to this, they want you to specifically use the graph to get the answer. Now, you've got to basically draw an imaginary line, well, draw a line, broken line, through the point where x is where y is equal to 0. In other words, what they're asking you for, guys, is the roots of the quadratic equation. What they're asking you for is very simply this, guys. They are asking you for the intercept on the x-axis. So one is right here, and of course one is all the way over here. That's where it crosses the x-axis. So we know that the scale here is there's 10 increments between the spaces between -1 and -2. So we know that this is 2.1 and this is approximately negative 2.2, 2.3, 2.4, 2.5. Okay, so each of these is 0.1, so that's negative. It looks like about negative 2.2. So this part here is negative 2.2. All right, and then all the way over here, then we're looking at, let's zoom up here for you. We're looking at, say, approximately, say here, 3.1, 3.2. So it's about 3.2 here, guys. Okay, so this one here is going to be approximately 3.2. Let me know if you got something different from what I got in the comments, guys. Okay, so therefore, then scrolling back down here, then we recognize that x then is equal to negative 2.2, and x is also equal to 3. Yeah, all right, fantastic. And now also on the grid, then on the grid, remember, guys, that this means that they're asking you for the roots of the quadratic equation, or they're asking you for what is known as the x-intercepts. Okay, so bear that in mind. On the grid on page 24, draw a line through the points -3, -1, and 0, 8. So let's go ahead and go on our graph and plot those points. -3, -1. So let's go here, -3, -1. So that's -3 all the way here, and -1 down here. That's right here. And then they also said 0, 8. Let's just confirm that. Make sure that we're on the right path. 0, 8. So 0, 8 is 0, and all the way up here, say 8 right here. Okay, so we must draw a line through that there. Okay, so it looks like a tangent to me, right? We've got to be a little bit careful here, guys. Let's see if we can get it really close. Okay, that's the best that I could do from here. So it seems as if this is actually a tangent to the curve. Okay, this is a tangent to the curve, guys. Okay, so let me know. Well, it's supposed to be drawn so straight that it basically touches that point right here. So let me know if you're doing the same thing as I am doing, guys, and you're getting the same there. Okay, so we've done that. We've drawn. It says determine the equation of the line formed determine the equation of the line in the form y equal mx plus c. So right away, then I know that since it's y equal mx plus c, I'm obviously going to need the gradient of that line. And so since I'm graphical, then, guys, I can simply then go ahead and use the formula rise over run. So rise over run is my graphical formula for finding the gradient. And since I know right away then that I could use any intersecting point. Okay, so since I know I am already right here, -3, -1, and say here 0, 8, I could use the formula. In fact, let's just go ahead and use the formula y2 minus y1 over x2 minus x1. So that's y2 minus y1. So that's y2 minus y1 over x2 minus x1. I'll just use the formula since I was already given the points here. Okay, so see here, this is x1, this is y1, this is, say here, x2, this is y2 here. Okay, so y2 then works out to be, say here, 8. Okay, so that's 8 take away y1 here, all the way over here is -1, so that's 8, take away -1, and that's all will be divided by x2, which is 0, take away x1, which is -3. So this works out nicely then to be 8 take away -1, that is 9, that's 8 plus 1 is 9, 0 take away -3 is +3, so that's 3, and that's equal, say here, 9 divided by 3 is 3. So right away I know that my gradient here is 3. This will be x. C is my y-intercept, and clearly you can see that the line that I drew crossed the y-axis at 8. So therefore then I know that my value here is going to be 8, and so that's it. Y is equal to gradient m, which is 3 times x plus y-intercept c, which is 8, and that is our final result. All right, so nice question there. Okay, again, we could have used rise over run if we wanted to, would have still gotten the same answer. -9 divided by -3, which is in fact +3. All right, so that brings us then to the end of the functions question for the May 2023 past paper. Let's move on to question 9, where we're going to be looking at some geometry and some trigonometry. Okay, this is one of my favorite topics to do, favorite topics to teach. It's a little bit challenging for a lot of students because your geometric skills and reasoning has to be top tier. So hopefully I can walk you through the thought process of this particular diagram then. Now, L, M, N, and R are points on the circumference. Now, you would have seen, if you watched the last solutions paper, you would have seen where I spoke about this particular sentence that CSEC uses a lot of the times. And whenever they use this here, they say L, M, N, and R are points on the circumference. They're trying to tell you that there is a quadrilateral that is inscribed inside the circle. Let us just go ahead right away and highlight that quadrilateral. So here we have here, and we have here, and we have this here, and we have this here. I particularly the approach that I take towards solving these questions, and remember that every student learns differently, every student sees the question from a different angle. I particularly, whenever I'm trying to work these questions on my own, I try to read the information and try to decipher some of the things that I might possibly need as I basically go along here. Okay, so I try to look at the information then and see what I can decipher. So since I've already looked at the fact that this here is a quadrilateral, I then need to ask myself, what is it that I know about a cyclic quadrilateral? So already I know that for certain that opposite angles in a cyclic quadrilateral are supplementary. I know that for sure. And if you guys did not know that, now you've just learned that the opposite angles in a quadrilateral are going to be supplementary. So right away then, without hesitation, I know that later on possibly this angle plus all of this angle will be added up to 180. And I also know that this angle here at A will also be added to this angle down here, and that also equals to 180. So that's what I do know already. Now let's continue. PQ is a tangent to the circle at R. So pardon me guys, I'm so sorry about that. Alright guys, so apologize for that breaking transmission then. So we're saying here that PQ is a tangent to the circle at R, and the angle PRL is 48. So PRL is 48. That's the angle that is at R, and it's a tangent to the circle. So already I know that the angle between a tangent and a chord theorem is going to come and play an important role a bit later. So I know that this angle here is going to be equal to, say, particularly this angle right in here. Okay, so already I know that the angle outside here between the tangent and the chord is going to be equal to the angle that's formed up here by the chord. You notice that the chord forms an angle right here, and it also forms an angle. These two lines form the angle right here. So in the event that they do ask me to find the L and R, I already know that it is equal to 48 because of that exact theorem. Now, what I also like to do, separate and aside from what they have actually given me here, I also love to look for diameters and radius, because I know that a diameter tends to form somewhat of a 90-degree sum here. So I do not see any diameter, but I also do see some radii. So I see a radii here, and I see a radii here. So I know immediately then that if I see radii, then I know that this angle in here, this triangle here, is going to be eventually equal to this angle here. And so I know that those two angles are equal, so I know then I can easily find that one later. So lots of little, clues are thrown about in the circle. You have to be able to decipher these before you dive on right in, because what usually happens is that as a student goes on to look at the questions being asked by CSEC, it tends to be a little bit confusing. So you want to try to break up the diagrams in pieces. What do I see? Do you see any radii? Do you see any diameters? Do you see any tangents? Do you see any chords? What do you see that can be of aid to you later? So now that we've gone through our little preliminary investigation of this diagram, let's look at exactly what is it that they're asking us to find. They said here, find the value of each of the following angles, giving reasons for each of your answers. Show all working where appropriate. So we're asked here to find the angle R. Okay, so right here then, we're looking to find the angle, say here, that is at R. Now, I know by looking at this diagram then that I can use what is called the central angle theorem. And so the central angle theorem basically states that if I have an angle that is created at the center of the circle, then the lines that connects the lines that is drawn to create that angle here, it will form an angle at the circumference. So if I use my yellow marker here, and just follow me for just a second here, guys. If I say here that this angle right here is 156, forms an angle right here of 156, then notice that these two lines also leads all the way up here and here as well. So right away then I know that this angle right here at R is going to be half the size of 156. So right away I can say that angle R then is equal to 156 divided by 2, and that's going to be equal to 78 degrees. And so the reason for this is, you could write simply the central angle theorem, or better yet, you could just simply say the angle at the center of the circle is twice the angle at the circumference subtended by the same chord. This is a bit elongated and hard to remember for most students, so a simple way to write this is just to say the central angle theorem. I think CSEC would accept that as a geometric reason. Alright, so that is it. So this angle right here is 75, and like I always encourage you guys, remember that once you find, say, an angle, place it on your diagram. It gives the diagram a bit more life. So that's this angle R then. Now let's go on then to look at, say here, angle E. And so angle E is all the way over here. So angle E then, what can we do about this? Now already I know that I could actually go ahead and find this little piece of angle in here. Okay, if I can find that angle in there, then I know that since O to R is a radius drawn to a tangent, I know right away that this angle here is going to be 90. E and this little piece of green angle right here, E and the green part here that I've shaded is going to be equated to 90. So if I can find the little green piece in here, I can subtract that away from 90 and I'll get it. So right away then I can just write a very simple equation here. I can see then that angle E is going to be equal to 90 degrees minus, let me give that green section of my diagram a name. So I can just name that, say, angle ORN. So angle ORN. So it's going to be 90 degrees minus angle ORN. The key then in finding this then is to find angle ORN. Now, since angle ORN, and if you're observing carefully, angle ORN is an angle that is in triangle ORN. So I know that inside the triangle ORN, I already have 156 degrees. And so therefore, these two green angles down here that I've shaded are going to be equal. So I can simply then therefore say that angle ORN is equal to 180 minus 156. And so divide that answer there by 2. So 180 minus 156, that's going to be equal to 24 degrees. And so if I divide that by 2, I know that those two little green angles there that I've shaded is in fact equal to, say here, 12 degrees. So let's scroll back up here again now, guys. And so we know that this angle right here is 12 degrees. And so this angle also right here is 12 degrees. So we did establish that this green piece here and the angle E that we're looking for adds up to 90. So by conclusion then, we can safely say then that therefore angle E then is equal to 90 minus 12, and that's going to be equal to, say here, 78 degrees. All right, that's really nice. Then that is 78 degrees. And now you might be looking and you'll be like, then okay, Apex, is it possible to make a connection between the angle that we found here and the angle that we found here? Now, just by looking at it now, just by observation, then we could see therefore that angle E was in fact an angle that is between the tangent QRP and the chord NR. So there was an angle created between this line here and this line here, and this chord here in fact created the angle that is at R. So therefore angle E is in fact equal to angle R. But what would be the statement? The statement would be the tangent theorem. Angle between the tangent and the chord is equal to the angle subtended by the chord at the circumference. That's also an option to get that answer. Alright, so whatever way you prefer, guys, let me know in the comments if you had a clear understanding. Then let's look at, say here now, angle A. So looking at angle A, then let's identify the position of that angle. Angle A, where are you? Angle A is all the way over here. And so already then we made an observation that angle A was in fact going to be supplementary to this blue angle down here. So this blue arc that I have right here plus this blue arc down here, they would have been added up to 180. So now I know that this is 12 and I know that over here is 90. So angle E is 90. This piece right here is 12. This piece over here is 48. If I could find this piece right in here, if I could find this little piece right in here, that would really do us a lot of justice then. So let me go about and finding this one. Already I know that since OR again is a tangent, pardon me, is a radius drawn perpendicular to the tangent, I know right away then that this angle right in here is going to be 90 minus 48. So I can say that LRO minus LRO is equal to 90 minus 48. So LRO, so angle LRO is equal to 90 minus 48, and that's equal to 42 degrees. So already this angle here is 42 degrees. All right, beautiful. Now that the angle is 42, I know therefore then that this green piece that I have here and this 42 gives us the sum of this blue curve that I have right here, this observation. So this green piece here, which is 12 that we had found earlier, and this 42, then that's going to be equal to, say here, 54 degrees. So therefore LRN is 42 plus 54, 42 plus 12, that's 54. So angle LRN, let's scroll back down here, angle LRN equals 42 plus 12, that's equal to 54 degrees. And so in conclusion then, since we have already established from the beginning, guys, that the angle A here is going to be supplementary to this blue curve that I have down here, which we just calculated to be 54. I can say therefore that angle A then is equal to 180 minus 54, and that then works out nicely to be 126 degrees. All right, and so the reason for this would have been the cyclic quadrilateral theorem, or you could just say opposite angles in a cyclic quadrilateral are supplementary, guys. Okay, all right, that is the reason then for that particular angle. So hopefully this helps you. All right, my best advice is your geometry skills have to be up to par when it comes to this particular question. It's tend to be a challenge for many CSEC students, but if you continue watching my other solution paper, you'll start to get a feel of how to approach these types of questions. It all boils down to you having good geometric observational skills, identifying radii, chords, diameters, tangent, seeing the relationship between the angles then. All right, so that brings us, I believe, to the end. Is it? Yes, it is to the end of that diagram. Let's then move on to this other section of trigonometry. The diagram below shows a triangular field LMP on horizontal ground LMP. Okay, we have a couple of measurements here. We have 120, 150, 180. Calculate the value of angle MLP. So that's MLP. So it's this angle that we're looking for in here. And this is kind of like very straightforward. If you are very much exposed to this aspect of trig, you'll right away know that this is in fact the cosine rule. And if you scroll up, which I won't do for you because sometimes my pages will disappear, but if you scroll back to the front of the exam paper for this particular exam, you'll see that the formula sheet has the cosine and the sine rule at the bottom of the page there. So let's just recall that formula. Cosine rule is in fact c squared is equal to a squared plus b squared minus 2ab multiplied by the cosine of the angle. Okay, now in this case here we have to be very careful of what we choose as our c, because our c value here heavily depends on the side that is in front of the angle given or the angle that we want. So in this case here, c would have to be 180 meters. So that's going to be 180 squared, and that's going to be equal to, the other two sides are 120 and 150, so that's 120 squared, and that's going to be 150 squared minus 2 times a and b. Already we chose to be 120 and 150 respectively, and of course we are in fact looking for the angle theta. Okay, so let's grab our calculators here, and just a second here guys, gotta grab my machine. So I believe 180 squared, that's going to give us 32,400. And that's equal to 120 squared. I believe that's 14,400. Let me just double check. That's correct, 14,400. And then of course we have 22,500. That is going to be 150 squared. Of course, 2 times 120 times 150, that's going to give us 36,000. So that's going to be minus 36,000 multiplied by cosine theta. Let's do some simplification here. That's going to be 14,400 plus 22,500. Pardon me, 14,400 plus 22,500. That's going to give us 36,900 here. Minus 36,000 times cosine theta. And a very common mistake made by students then is they go ahead and they subtract these two numbers. Remember that the 36,000 and the cosine theta is attached by the multiplication sign. So in this case here, the only other option here is to transpose, say here, the 36,900 over here. Or better yet, what I like to do is that I prefer telling students to carry the negative cosine theta to the right side and bring in the 32,000 to the left side, 32,400 to be precise. So I prefer doing it that way because it keeps my cosine positive. So cosine theta, 36,000, pardon me, cosine theta is equal to 36,900 minus 32,400. So that's 36,900 minus 32,400. That gives us 4,500. So that's 36,000 cosine theta. That's equal to 4,500. So if we divide this 4,500 by 36,000, we're going to get 0.125. So if I divide both sides by 36,000, divide over here by 36,000, cancel, cosine theta equals 0.125. So inverse are the arc costs of that value. So you press shift or second function and you press cosine, you should end up that theta then works out to be cosine raised to the minus 1 of 0.125, and that's going to be, see here, 82.8, which is approximately equal to 83 degrees rounded off. All right, and that's going to be how you get the solution to that particular question then. All right, fantastic guys, that's how you get that done. Now let's move on then, but before we move on, let's put our answer on our diagram then. So we can just erase this here and we can put, say here, 83 degrees on our diagram then. Let's just erase this and erase that. So now we have a better looking diagram. Okay, let's then move on all the way down to this section here. It says the bearing, we are to calculate the bearing of P from L. Well, they're telling us that the bearing of P from L is 210. So the bearing of P from L, so we have to draw a north line at L. So if we draw a north line at L and come around like that all the way to P, that angle is going to be 210. So let's go on our diagram here. A north line is already at L, so just coming around like this then all the way to P, that's going to give us 210 degrees. Okay, noted. Alright, so that's noted, and we have a part of it which is 83 already. So let's see here, we have to use this information then and find the bearing of M, this time from L. So from L we already have our north line, but this time we are trying to go to M, so we need to go around to this section here. Okay, so from north come around to M. That's this direction that we're trying to find, this angle right here. Now, when you get a situation like this, guys, the best approach is to draw some auxiliary lines then. Alright? Now, for this one here, since we know that the full angle is 210, and a part of it already, excluding the bearing of M from L, then we can just, this is very simple then, we can just subtract the 83 from 210. So that wasn't challenging, it's just 1 mark. So therefore then, to get that, it's going to be 210 minus 83 degrees. And that's going to be, let's double check, 210 minus 83, that's 127 degrees. And it sounds reasonably correct, and it looks reasonably correct. So that's 127 degrees. Then let's just put that on our diagram because it may be helpful with our visualization later on. So this right here is 127 degrees then. Right? Looks fairly reasonable to me then. Alright, let's move on then to this part. Not see much of a challenge then as yet. Calculate the value of angle NLP. Calculate the value of angle NLP and hence find the bearing of L from P. So NLP, we need to calculate that value. Let's go back here. NLP, where is that position? NLP. Okay, so N is the north, so NLP, this angle right here. Okay, so that's not too bad. NLP, north LP, that angle on the outside. We know the full angle is in fact 360 degrees. Already we know coming all the way around here is 210. So I know right away then that this particular angle that they're requesting of us here. Okay. So angle NLP is going to be 360 degrees minus 210. So that's 90. That's going to be 150 degrees already. So that's angle NLP. So that's 360 minus 210. And so they say, hence now we should find the bearing of L, but this time we have to measure it from P. So we need a north line. So let's get our north line at P and go all the way around to L. So north line at P. So north line at P here. And we need to go all the way around to L. Remember that a bearing is measured in a clockwise direction. So all the way to L, we're looking for this angle right here. Okay, this angle right inside here. Now, since the north line here is parallel to say here, this north line all the way down here, we know that an alternate angle will form. So north come all the way up here. If I make an auxiliary line to create a south line here, so let's just zoom up a little bit here for you guys. Let's create an auxiliary line. It forms a Z. So whatever this angle is that we're looking for down here, whatever this angle is going to be exactly equal to this one right here. So I just need to find this angle right here. Let's call this S, south. I just need to find this angle and I'll automatically find NPL. Okay, so therefore then let's just make some statements. Let's make some thesis statements here. All right, so we can say that NLP. Okay, so let's go ahead then. Okay, hold on guys, let me just make sure that I have my points correct. So that's this N, NPL so angle NPL, this is the N at the bottom, is going to be equal to the angle N at the top, L. So that's, just double check here guys before I write my statement. So this angle here is going to be N or I should say it's going to be PLS. Pardon me, it's PLS, guys. So angle NLP is going to be equal to angle PLS. Okay, so we know that that's for certain. This statement was made simply because I want us to recognize that these two green spots that I've identified here, N, P, L, and PLS, are alternate angles, so they are equal. So if I want to find NPL, all I have to do is find PLS and I'm good. Okay, so how do we find PLS? Well, since from north to south is 180, and I know that the bearing of P from L is 210, I can subtract the 180 from 210. All right, so that's a nice statement there. So then right away then, my conclusion then, or my concluding statement then, is going to be that angle PLS is going to be equal to 210 degrees, which is the bearing of P from L, minus the north-south angle. That's 180 degrees. So this right away is going to be 30 degrees. So right away then, I know that this angle here is in fact 30 degrees, because from north all the way to south here, north all the way to south is 180, and I have 210 coming past it, coming around like that. Then I know right away that that angle inside here is 30. Therefore then, this angle also out here is in fact 30 degrees as well. So therefore, in conclusion then, that since we already established that NLP, which is what we're looking for, is going to be equal to PLS, then therefore then the angle NPL is also equal to 30. Therefore, in conclusion then, that the bearing L from, so bearing L from P equals 30 degrees as well. And just a little reason here, alternate angles are equal. Okay, that helps out the situation then. All right, beautiful. So that takes care of that question. Okay, you gotta focus, guys, when you're doing these types of questions, because you can easily get confused. So you have to really focus on your geometry skills, and observational skills have to be top tier. All right, so that brings us to the end. I've seen more challenging questions than this one. So again, I still feel like CSEC did not really attack the students on this particular paper. They didn't attack the student as much as I thought they would have when it comes to tricks. So it was a very doable question, in my opinion, in my humble opinion then. All right, so here let's move on to say here vectors and matrices here. All right, now the matrices, pardon me guys, the matrices A and B represents the transformation given below. A 0, -1, 1, 0 represents an anticlockwise rotation of 90 degrees about the origin, and 0, -1, -1, 0 represents a reflection in the line y equal -x. Determine the elements of the matrix C, which represents the anticlockwise rotation of 90 about the origin, followed by a reflection in the line y equal -x. This is a very nice way for CSEC to ask you to multiply the two matrices. So they're basically asking to combine the rotation with the reflection. So our matrices skills here is going to come into play. So that's 0, -1, 1, 0 multiplied by 0, -1, -1, 0. This is a nice way for CXC to actually ask you to multiply the two matrices. So row by column, then we have 0 times 0 is in fact 0, so that's 0 times 0 and -1 times -1. So that's going to be 0 times 0 is 0 plus -1 times -1 is 1. Then we're going to go 0 times -1 is 0, and then -1 times 0 is in fact 0. Now we're going to go ahead then and go to the second row here. So that's row 2. So that's row 2 with column 1. So that's 1 times 0 is 0, and 0 times -1 is in fact again 0. And then finally this row here with this column here, 1 times -1 is -1, and 0 times 0 is in fact 0. Okay, and so therefore then 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 is 0, and -1 plus 0 is -1. So this is the matrix that we're looking for here, the combined matrix. All right, beautiful. So hopefully you guys get that whenever they ask the question like that, you know you have to combine the matrices. It says describe fully the single transformation represented by C. So this basically is the matrix C. So we should describe this. Now it's a bit challenging for many students, for a teacher or for a really good math student who have the whole matrix, the 1 0 0 1s in their mind. It's a bit challenging for many students. So you have to have a basic idea of what's going on here. So I know right away that this matrix here is, I could just label this here X, label this Y, label this X, label this, say here, Y. So I know that there's one X here. So I know that whatever this is, whatever this matrix is, I know that XY basically is going to be transformed to, say here, I have one X at the top, and I have no Y at the top. Then I have 0x at the bottom and -1y here. So what this implies for me then is, if I could remember correctly, and what I want you guys to do is to go back to my reflection tutorial. I will pin also a link in the description of this video. Check out my reflection video. You will be familiar with this type of setup here, say here. Okay, so when the X remains the same and the Y changes, this basically is a reflection in the x-axis. So therefore we can safely say that the combined, so basically the combined transformation, or let's say the transformation C is a reflection in the x-axis. Okay, so it's a reflection in the x-axis here. All right, and so to know this, guys, there is not really like a set way. Well, at least in my experience, there's not a set way to like per se know exactly what it is. You have to have that little skill where you label your entries inside the matrix, and then you just observe if there's any more x's or y's at the top or the bottom of the point or the vector, and then you kind of see the change that occur. Okay, so if you can get yourself familiar with the different changes that occur in an x-axis, y-axis, y equal x, y equal -x, or a rotation, then you definitely, it would be very helpful then. All right, now that is in fact your answer there. Transformation C is a reflection in the x-axis. All right, beautiful. Let's move on then to this section here. The transformation T, right, which we had up here, is defined by, well, the transformation T, this T here, is defined by the following 2 by 2 matrix, 1 2 k -1, where k is a constant. T, which is the matrix here, it basically mapped 2 3 onto the point 8 15. Determine the value of k. So this clearly is not any of our standard transformations like reflection, rotation, enlargement, nothing like that. It's just basically a transformational matrix. Now the rule still applies that a matrix multiplies by the object will give you the image. That's what basically we know for certain. So this matrix here, T, is going to be now T multiplied by the object here that will therefore give us the image. So the matrix T here, which is 1, 2, K, negative 1, it's going to multiply the object, which they say that the point T maps to 3. So that's going to be 2, 3. And it maps it onto, say here, 8, 15. So what we have here is a matrix equation that we need to solve. Okay, so once again, if two brackets are joined together, guys, you're going to row by column. So that's going to be 1 times 2. That's going to be 2 plus 2 times 3. That gives us 6. Okay, and then we have k times 2. That's going to give us 2k plus negative 1 times 3. That's negative 3. And then obviously then that's going to be equal then to, say here, 8, 15. Okay, so obviously then you can see that 2 plus 6 is in fact 8. So we know that that's 8 already. And already now we have 2 plus negative 3. That's going to give us negative 2k minus 3. Pardon me, not negative 2k. Pardon me, guys. Not negative 2k. It's going to be just 2k minus 3 in that bracket, and that's going to be equal then to 815. Okay, so clearly you can see that the 8 is in fact equal to the 8, so that's no problem there. But then we end up with 2k minus 3 is equal to 15. We can solve this equation here, bring the negative 3 over, so that's going to be 2k is equal to 15 plus 3, so that's 2k is equal to 18. Therefore then k is equal to 18 divided by 2. K is equal to 1. Okay, so that means 9 is the answer that is supposed to, that's the value that is supposed to be right there in that matrix then. All right, fantastic. Okay, so not too bad there. Nice little transformation question. Please be open-minded, guys, that in disregard whatever it is that you're taught in your class as it relates to standard transformations. You may get questions like this where CSEC decides to give you just a random transformational matrix, but the principles remain the same, that a matrix multiplied by its object will give you the image then. All right, and so now we move on to the last question here, part C, the vectors aspect. Okay, so the following vectors are defined as shown below. Wx is 5, negative 1, xy is minus 3, 7, and zy is 8, negative 7. Determine each of the following a vector other than 5 minus 1 that is parallel to xy. Now, when I get questions like these, I particularly like to do like a little sketch, okay? Because oftentimes my instructor back many years ago would tell me that a picture tells 1,000 words. So we're looking for a matrix that is parallel to Wx, and we know right away that Wx is in fact 5, negative 1. So you have to have some sort of idea as it relates to parallel lines. Now, basically, if two lines are parallel, we can, one of two things can happen. They can have equal lengths, okay? Or we can actually have, say here, one vector is k times the other. So one of these vectors up here, one of these combination vectors up here will be something maybe 2 times or 3 times or half the size or half the length of the other, or they might have equal length. So it says that we should determine each of the following. We need a vector other than 5, negative 1 that is parallel to Wx. All right, so let's see then, how do we approach this question then? I like to make a sketch, okay? That's what I prefer doing. So if I go ahead then and I draw a Cartesian plane here, and I just just make some sketches then. Since Wx is a free vector, I can pretty much put my W anywhere. So I'm gonna just go here, 1, 2, okay, 2, 3, 4, 5. 1 2 3 4, say here 5. 1 2 3 4, let's say 1 2 3 4. Okay, so I'm just gonna put my W anywhere, and you can do the same thing as well. Okay, I'm gonna put my W right here, right at this position right here. Okay, that's my W. So I know that to go towards X, I would have to go 5, negative 1. So that's gonna be 1 2 3 4 5, and go down 1. So I know that my X is gonna, based on where my W is, that's where my X is going to be. If you guys place your W elsewhere, it's gonna have a similar route. Okay, so you're just gonna use the points on the axis here. So that's gonna be my X here. Okay, so WX is 5, negative 1. Okay, I know that from X to Y then is negative 3 7. So I'm gonna go from X then 1 2 3, and I'm gonna go up 7. Okay, so that's going to be 1 2 3 4 5 6, just a little bit up here. Okay, maybe I needed to like perhaps maybe draw this a bit clearer in a bigger space. So that's, anyway, that's going to be my Y here. So that's X to my Y. So I'm looking for something parallel, and ZY then, well, I don't know where Z is, but I know where Y is. So since I know that ZY is 8, negative 7, then I know that YZ is the inverse of ZY. So that's going to be negative 8, positive 7. So from Y then, I'm going to go negative 8. So that's going to be in line right here. So it's going to be 1 2 3 4 5 6 7. It's going to be a little bit out here. I really should have drawn this in a bigger space. So I'm just gonna make a guesstimate. Okay, it's a little bit tricky. Okay, that's not gonna work. That's definitely not going to work. Okay, so let's do okay, tricky guys, just a sec, let me just get my graph right. Alright guys, so I think I might have gotten a better graph here. So let's just go ahead and just go through this process again. So we have WX. I'm going to be placing my W, say here at this position here. Okay, and then from here I'm going to move, say here towards X. That's 5, negative 1. So that's going to be 1 2 3 4 5. And then I'm going to go down 1. So I'm going to be right here on this position here. Okay, so that's here 1 2 3 4 5, down 1. Okay, so that's going to be my X right here. This is going to be my W here. Then of course, then I'm going to move from X then to Y. So that's negative 3 7. So that's going to go backwards then 1 2 3, and then I'm going to go up 7. So that's going to be 1 2 3 4 5 6 7. So that's 1 2 3. Okay, so that's 1 2 3, and it's going to be up 7. So that's 1 2 3 4 5 6 7. So that's about here somewhere, there about. Okay, I think I'm in line here. Okay, so that's going to be my Y, and so therefore then now I need to go to Z. So ZY. Now I don't know what where the position of Z is, but I know where the position of Y is. So if I can get from Y to Z, then that's easier. So since ZY is 8, negative 7, then it means that YZ is the inverse. So that's therefore going to be negative 8 7. Okay, so it's the inverse, the negative of the vector. So from Y, where I'm at located now, I'm going to go negative 8. So I'm going to be in line with 3. So that's 1 2 3 4 5 6 7 8. And then I'm going to go actually down 7. So I'm in line here. Let's put that as 8. Okay, so that's going to be 1 2 3 4 5 6 7. Okay, so that's going to be 7 8. I'm right here in line here. Okay, so I'm in line in this position right here. Hold on guys, right here, I'm in that position. All right, perfect. So then I'm going to go from in this line, I'm going to go down 8. So that's 1 2 3 4 5 6 7 8. I'm going to be down here. Okay, I'm going to be 2 steps below here. So that's right at this position here. Okay, it's a little bit out of sorts, guys, a little bit out of sorts, but it's going to be fine. So that's going to be Z. So then I know right away that these are all the points that I was given. So I'm looking for a vector other than 5, -1 that is parallel to, say here, WX. Which other line may be parallel to WX? Well, do not see any at the moment. This is the line WX. And every other line that I connect, they're not parallel to that. Okay, let's see here. Now in a situation like this, where you plot your points or you make a sketch of what's going on here and you're not really seeing any lines that are particularly parallel, I think basically in my observation here, it seems if we already established that a vector can be parallel in 2 ways. It's that they can have of the same length, or it can be k times whatever the vector is. In this case, it's going to be k times, say here, 5, -1. So that means one vector could be twice as long or half the size of the other. Whichever one you choose is going to be parallel to 5, 1. So I'm guessing then that maybe you could choose any constant here for k, or you could just simply just say 5k and say here -k. So that's k times -1 is -k, 5 times k. So this vector here, any value, any constant that I choose for k here will provide, say here, a parallel vector to WX. All right? So that's just really the reasoning behind this question. I was particularly thinking that maybe either XY or ZY or XY might be parallel to WX, but just by the little mere sketch here that I've done on the diagram, it doesn't really show much here when it comes to any of the particular lines here being parallel to WX. So I'm guessing here that the answer is going to be whatever it is that you write down. You could choose a value for k if you want, 2, -2, 3, -3, a half, a quarter, or whatever it is that you choose, it's going to be parallel to, say here, WX. All right, so that I think is the answer. Now WY, that's the vector that we're looking for, WY. So if we can connect, say here, WY, that is in fact, let's just get that back there. Okay, so WY, boom, like that. Then if I can create some sort of triangle, let's create a triangle with WX here and here. Okay, let's sketch like that. Then I know right away that for me to calculate the coordinates of this vector using the diagram, then it simply means that W, say here, WY, then it's going to be equal to going around the triangle. So here's WY. I'm just going to go this way instead, WX plus XY. So that's WY is equal to WX plus XY. That is the triangle laws of vectors. Now, if we go back up here, we see that WX is in fact 5, -1. And XY then is -3, 7. So that's -3, 7. So therefore then 5 plus -3, that's 2. And -1 plus 7 is 6. So that would be the answer for WY26. All right, and so this little sketch that we've done here gives us an idea of how the vectors are connected. Then XZ. The reason why we have to do it like this is because the vectors that we're looking at, they're all free vectors that are drawn randomly in the Cartesian plane. So therefore then there's no fixed point like the origin. Okay, so you have to really be able to like make a sketch of this and see what's going on. So XZ, let's draw a line from X here to Z like that, and we could use this triangle right here, connect W to Z. So X to Z, put our arrowhead like that, X to Z is going to be X to W plus W to Z. So XZ is equal to X to W plus W to Z. Now X to W is in fact the inverse, say here, of x to w is the inverse of wx. X to w is the inverse of w to x. Remember, w to x is 5, negative 1. So that's 1, 2, that's 1, 2, 3, 4, 5. So that's 5, negative 1. Okay. And so the inverse of xw then is going to be negative 5 up 1, because it was in fact 5, negative 1. So it's negative 5 up 1 plus then wz. Let's look up here. Wz. Do we have wz? Did we calculate wz? Okay, so wz then. Wz is going to be inverse of zw. And do we have zw? We don't have zw, guys. So zw, that's going to be interesting here. zw. Okay. Let's try to figure that one out. Alright, so the only way to really do this is to perhaps, hopefully you have a detail sketched, then you could actually go ahead and read it from the graph here if it's accurately plotted. So here I know that I'm looking for z to w, so I'm just going to go, say here, 1, 2, 3, 4, 5, 6, and I'm going to go up 2. So that's going to be 6 up 2, 6 up 2. Okay, 6 up 2. So that's going to be 6 up 2. That's that right there. Reading it off the graph. Okay, 6 up 2. Alright, and then that's pretty much it. And then we just go ahead then and we add negative 5 plus 6, that's equal to 1. And 1 plus 2 is 3. So there we have it. 1, 3. Okay, alright, and now that pretty much asks us then to calculate, this means the length of the vector xy. So length of xy, we know that xy here is minus 3, 7. So that's minus 3, 7. So this is going to be the length of minus 3, 7. And this is the Pythagoras theorem, of course, in vector form. Okay, so that's going to be square root of x squared plus y squared. So the x squared is going to be square root of minus 3 squared plus 7 squared. So that works out then to be the square root of 9 plus 49. And that's the square root of 58. So you can leave that in decimal form or leave it in, say here, third form. So that's squared root. Okay, so that's square root of, say here, 58. And that's 7.62 or 7.6 units. 7.6 units then. Alright, so that pretty much brings us to the end of the examination. The vectors was a little bit tricky. It's tricky in terms of how the question is worded. So a little experience there would help you in terms of having an understanding of how to proceed with this particular paper then. Alright, so that brings us to the end of the whole entire series of videos for 2023 May-June exam. I do hope that it was quite helpful to all of you and you guys can continue learning as you go along. Alright, so until next time, this is your math instructor Apex Elenio, and I will see you in another tutorial coming up next on the channel. You're going to find the January CSEC exam solution paper coming up in a few days, so do check that out. Be sure to be subscribed to the channel, hit the like button, leave your comments and thoughts down below, and I'll see you in another one. Take care.